Naman Gagan, as we had discussed earlier with you, that I'm going to produce a video for the tanking series model so that you can understand that better. So, yeah, today we are going to start with the tanking series model basically. So, now, first let us understand that what does this really mean when I say that tank in series model. Okay, now consider a PFR. Consider a PFR has some concentration C naught and an exit concentration C. Okay, now what we consider in ideal cases, if I talk about the ideal case, what do we consider is there is an element at that single point of time where the reaction is actually taking place. Okay, as we move forward, each element has its own conversion. Okay, this is ideal case. But now let us understand what would really happen in a real case for a PFR that does not behave ideally but behaves really in a real way. What would really happen as it goes inside? Not just a fluid element would be reacting, but there would be some kind of back mixing. Why? Due to the forces on this wall, due to the viscosity of the liquid, or something else. There would be a mixing taking place. It won't be a perfect laminar flow that would flow through the tube of PFR. Okay. Now, consider a case of PFR wherein those elements that I was talking about, these elements that we are considering small parts of the PFR. Okay. Now consider that there are lots and lots of them. Fine. And when I'm talking about back mixing, it is some sort of mixing. Okay. So if I say that in this PFR I have made very small sections and I have put an agitator into them so that the mixing occurs. Okay. Now if you just consider this one part, what is this? What is this? This is a CST. Perfect. So what I can say, a PFR is made up of a finite number of imaginary CSTs. Okay. So to study the complete concentration change and the profile of concentration over a PFR, what we really need to do is we need to study complete PFR in form of CSTR in series. Why? Because there is a back mixing happening, so we can't really put this PFR in terms of ideal PFR. But if we study this PFR in small sections of ideal CSTRs, because there is 100% mixing in CSTR. Okay, so there is one case of ideality where is when there is 0% back mixing, or when there is 0% mixing, and there is a real case where it can be up to 100%. So when we are talking about PFR, it can go from an extreme, lower extreme of 0 to a higher extreme of 100% mixing. Okay. So when we are moving from 0%, like when we say there is 0% mixing, it is ideal PFR. And when I am saying 100% mixing, it is a continuous series of CSTRs, imaginary CSTRs, that we can put it into these PFRs. Okay. So a single PFR would be consisting of many more CSTRs when we are considering 100% mixing. So we will study, or we will basically compare that from 0% mixing to 100% mixing in a PFR, what is the change in concentration, or how basically the concentration changes with time. Okay. So to study this, we need to break down all this PFR, all the complete PFR into CSTR in series, and then study these CSTRs individually, and then add them up totally, so that we get the final equation for this PFR, but we have studied it in the way of tank in series model. Hope that's clear to you. The further section of this part would be continued in the next video.